Start with the great name of Allah who is Rahman and Rahim. My name Kashif Alim with my group member Akib Ali Abasi from 20 Batch Electrical Engineering Department. Our presentation in the supervision of Sir Qurban Ali Shah on the topic of MOSFET. What is MOSFET? Working principles and applications. The MOSFET stands for metal oxide semiconductor field effect transistor. A transistor is a semiconductor device widely used in switching purpose and for the amplification of electronic signals and electronics devices. A MOSFET either a core or integrated circuit where it is designed in a fabric in a single chip because the device is available in very small size. The introduction of MOSFET device is brought a change in domain of switching in electronics device. Let's go with the detailed and applications concept of it. What is MOSFET? A MOSFET is a four terminals device having source S, gates G, drain D and body B terminals. In generally, the body of MOSFET is in connection with the source of terminal, thus forming three terminals device such a field effect transistor. MOSFET is generally considered as the transistors and employed in the both the analog and digital circuits. This is the basic introduction of MOSFET, and the general structure of this device is as below. From the above MOSFET structure, the functionality of MOSFET depends on the electrical variations happening in the channel's width along with the flow of carries either holes and electrons. The charge carries entire into the channel through the source terminal and exit via the drain. The width of the channel is controlled by the voltage on the electrode, which is called a gate, and it's located between the source and the drain. It is insulated from the channels near an extremely thin layer metal oxide. The MOS conceptually exists. The device is a circular selection where the entire operation is occurs this. A MOSFET can function in two ways: depletion mode in enchantment mode. Depletion mode in where 3 is no voltage occurs the voltage gate terminal. The channel shows the maximum conductance. Where the voltage across the gate terminal is either positive or negative, then the channel conductivity decreases. Please refer to the link. Encochment mode: when the voltage across the gate terminal, then the device does not conduct. When there is the maximum voltage across the gate terminal, then the device shows enhanced conductivity. Working principle of MOSFET. The main working principle of MOSFET device is to be available to control the voltage and flow current between the source and drain terminals. Its work almost like a switch into the functionality of the device based on the MOS capacitor. The MOS capacitor is the main part of the MOSFET, the semiconductor surface at the below oxide layer, which is located between the source and the drain terminal, can be inverted from a P-type to N-type by the application of either positive or negative gate voltages respectively. When the apply a source or apply force for a positive voltage, then the hole present behind the oxide layer are pushed downward with the substrate. The depletion region are populated by the bound negative charges which are associated with the acceptor atoms. When electrons are reached a channel and developed, the positive voltage also attracts electrons from the n-type, n-positive type and drain region into the channel. Now, if a voltage is applied between the drain and source, The current flow freely between the source and drain in the negative voltage controls electronic channels and instead the flow of positive voltages. If we apply a negative voltage, a whole channel will be found under the oxide layer. MOSFET region of operations. To the MOSFET general sensor, the operation of the device happens mainly in three regions, and those are the as follow: cut-off region, saturation region. Cut-off region, it is the region where the device will be off connection and there zero amount of current flow through it. Here the device function as the basic switch and its employed is as when they are necessary to operate the electrical switches. Saturation region, in this region we device have their drain to source current flow is constant without considering the encroachment of the voltage and across the drain to source. This happens only once when the voltage occurs the drain source terminal increases more than the pin off voltage value. In the synchronous, the function is closed switch where the saturated level is current across the drain source terminal flows. Due to this, saturation region is selected when we devices are supposed to perform switching. Linear ohm region. In this region, we discuss about occurs the drain source terminal enclosed when the increment in the voltage occurs to the drain to source path. When the MOSFET device function in this layer region, they perform amplifier functionally. Let us now consider switching characteristics of MOSFET as semiconductors to such as MOSFET or bipolar junction transistor is basically function as a switches into the sensors. One is on state and the other is off state. The consider this functionally. Let us have a look at the ideal and practical characters of the MOSFET device. Ideal switch characters. When a MOSFET is considered functional as a device, it should have below properties, and those are the on connection. There has to be current emulation that is carries. In the off connection, blocking voltage level should not hold any kind of limitations. When the device's function is on state, the voltage drops value should be null, and the resistance of in off state should be infinite. There should have no resistance reactions radiations on the speed of operation. Ideal switch characteristics. When a MOSFET is supposed to be functional as ideal switch, it should be a loop properties, and those are on condition there has be current limitation of current. In off connection, blocking voltage level should not hold any kind of limitations. When a device is function on a state, the voltage drops value should be null. The resistance in off state should be infinite. There should be no reactance on speed of operation. Particle switch characteristics. In is the world just not stuck of ideal application? The functioning of MOSFET is even applicable for a particular purpose. In the particle synchronous device should have allow the properties in the on connections. The power magnetic abilities should be limited, which means the flow of connection current to resist the off state. Blocking voltage levels should not be limited. Turning on and off for finite times rejects the limitation speed of the device, even this functional frequency. In this on connection, the MOSFET device, there will be minimal resistance. The value of air is resistance in the voltage drops in the forwarding base Also, there is exits finite of state resistance. This device reverse leakage current. When the device performing the particular characters, it loses power on and off condition. This happens even the transition states too. Here we are presentation the end. Thank you so much.